Hi guys, welcome to another video tutorial where we explore interesting dApp projects on the Rootstock blockchain. Now in this tutorial we're going to be building something called a Payroll. So the title of the project is RSK Payroll. It is simply a UI that allows users to send RBTC, but now in this case, test RBTC to multiple addresses in one go with just a click of a button. So we're going to have our users enter addresses and the amount of RBTC, and they can input as many as they want in rows, and then with the click of a button they can send RBTC to all those addresses. Isn't that interesting? Alright guys, so but before we dive into this concept, let's talk about Rootstock. Alright, so what is Rootstock? Rootstock is an amazing layer 2 EVM compatible blockchain which is built on the Bitcoin security layer. Now imagine you have an EVM compatible blockchain. That means a chain that you can deploy your Solidity smart contracts on and has every other capabilities that all other EVM compatible chains have. And now it is built on the security layer of the Bitcoin. That means it has the backing of the Bitcoin. In fact, the native currency of Rootstock, which is the RBTC, as I mentioned earlier, is backed by the Bitcoin. So the name is RBTC. It is pegged to the Bitcoin. So gas prices don't fluctuate anyhow. It has a stable gas price, and like every other layer 2 blockchain, it has a very, very low gas fee. Now this is why you should build on Rootstock, because you have low gas fees, you have fast transaction speed, it has high block finality time, it has Rootstock chain also has, like I said earlier, the security backing of the Bitcoin. That means whenever you're building on Rootstock, you are built like under the hood, it's supported by the security layer of the Bitcoin. And even aside the technology part, there are lots of incentives and initiatives that the Rootstock protocol offers. An example is the Rootstock Collective, as you can see here. You can either stake your RBTC or your tokens here to get rewards, or you can come in as a builder and build amazing stuff, and then you get backed. You get people to fund, get the community to fund your project and everything. So this is just one. Then there is the activator. So I have been a contributor to the Rootstock activator for some time now, and it's been really cool, guys. It's been really cool. We get to see lots of interesting projects. So the way this one works now is that you can contribute ideas, or you can contribute you can work on ideas that have been contributed already. So that means even if you don't want to work on an idea but you just have it, you could just come here and drop it, and then people can take it up and do it. Isn't that cool? So you can get to, like, okay, work on those ideas, or work on the ideas that have been submitted by people. All right guys, so these are like initiatives that the Rootstock protocol has. Then there's also the Rootstock community. They have a growing and an active Discord community that is open to everyone. So guys, build on Rootstock today. Now back to what we're working on today, the agenda for today. We're going to build a simple payroll system on Rootstock, and here are some prerequisites. So you should have a basic front-end understanding. That means that you should know some React. We're going to be using TypeScript for this project. So also Tailwind. We're not focusing on styling, styling a button, all those things. Like, I mean, at this point in time, AI can do all of that. So we're not necessarily bothered about all those type of things. What we're focused on is how to connect the smart contract logic, how to bring that into the front end, and how to manipulate data on the front end, how to manipulate state on front end, and ensure that the smart contract and the front end, like, they plug in together. So that's what we are focusing on. So you should by now, to follow up with this video, you should be able to deploy smart contracts, basic understanding about smart contracts. Alright, so in terms of software, you should, have Git installed, Node.js. You have a browser wallet like MetaMask or Rabi. Yeah. So you should also have, added Rootstock Testnet to your MetaMask or to whatever browser you're using. So, and if you want to add manually, you can do it this way. The instruction is here. Now you need to get testnet token, which is the test RBTC. You can get it using the link here. And now to the process of setup. Now this project we have a scaffold already, and that scaffold is basically a React front end which has already been connected using AppKit SDK. So there's like AppKit SDK and there's the Rainbow Kit SDK for wallet connection. But now this project uses AppKit SDK, and it has kind of like some basic configuration that has been done to ensure that okay, the process of building is very seamless. So I'm going to go through it, but if you are not following the setup, you are free to go with whatever setup you're going with, because at the start of the video I'm going to explain the setup. Alright, so let's dive right in. So let me just check if this is if what we have here. Come, just give me a sec. I just want to see if yeah. So I don't want to I want to ensure that my screen is not frozen. Alright guys, so let's dive right in. Okay. So now I have already cloned the project, and let me show you. So we have Git branch. Now this is the scaffold, and from the scaffold branch I created a new branch called a tutorial branch. So what we have here is basically the scaffold, but then I'm on a new branch where I'm going to be making all my changes. Alright guys, so let me start from the env sample file. So you need to get all of this. So you need your Explorer URL, the RPC URL, the project ID, AppKit project ID. So you need to get this from Reown AppKit, else you won't be able to like connect your wallet. Then you need the payroll contract address. So all of these are in my env. I don't want to show you. Yeah. So you need to get yours. Okay, so I think if you are on the, so we can see the RPC here, we can see the Explorer here. Then to get your project ID for AppKit, so go to Reown. You need to log into Reown AppKit to get yours. So you need to log in. I think the URL for this is cloud Reown cloud login. Okay, yeah, so you just log in here to the dashboard and then get your project ID. So with that said, let's go into other areas. So we have, let me go to the package.json. Okay, so we have Tailwind installed, we have React Testify for the toast messages, we have Ethers decode errors. So this will help us decode errors in smart contracts. Alright, and then these are the other dev dependencies which comes with React. So we have AppKit here, AppKits and AppKit adapters. So all of these have been incorporated into the scaffold. Now some other important stuff we should be mindful about is so the use runners. So this is basically a hook that gives us access to provider, signer, read-only provider, because if you're familiar with normal smart contract integration, be able to interact with smart contracts, we need a provider. So this hook here uses AppKit provider and create for us a wallet provider. Now we're not passing the provider out, we're exporting it out here so we can use it in the use contract hook. So the use contract hook is basically a hook that creates a contract object, and now it creates two types of contract objects. The first contract object is the one with signer. So this is a contract object that will cause us to sign a transaction via MetaMask or whatever browser you're using. And the other one is a read-only contract object. So this one is only used for reading data from the smart contract. And now all these are controlled by this with signer. So the with signer property here is when it is true, that means we want a signer, and if it is false, we don't want a signer. So that's how this now we have two contract hooks. We have the use read hook and we have the use write hook. Let's look at our smart contract. So I've already deployed this smart contract already. Now if we look at the smart contract, it only has one function, distribute, and it is a write. So we don't need read. We don't need to write like hooks for reading. All what we need is to write directly. Okay, so our focus for this project is going to be on write. Now let's look at the app.tsx. Let's see what's going on. Okay, so we have let's see. So just forget the red lines. So we are mapping through some data here, and we are rendering inputs. So I know this will not make a lot of sense. Let me run this. When I run this, it's going to make sense. So we have a connect wallet button here. Don't forget to put in your AppKit ID, else this will not pop up. This will not pop up. Okay, so now this input, the two inputs here are what we had here. So these are the two inputs. Then we have the delete row. So this is because we can add multiple rows, so we can delete them also. So that's why we have this. And this is where we have the add row button, and we have the send payment button. But now you see, if we try to hit send payment, we say connect wallet first, and all that logic is handled by the send payment function. And then okay, we can also see the toast container here. So this is the send payment function. I think this is the main function we have here. Aside the send payment function, we have the delete row. This is what deletes a particular row from the UI. Okay, so it does that by filtering out, using the index. Then we also have the handle input change, which will help us store whatever user is typing into the address and the amount fields. Okay, so we have this state. So this is coming from the use AppKit account. If connected is checking if the user is connected. Then we have the address. So this would give us the address that the user connects here. So when the user like okay connect, the address that is connected via the wallet will be returned. Now the open here is the function that handles the opening of the modal. So I think one more thing I'll just talk about is the connection. So this is a file that uses the AppKit SDK to handle the wallet connection. So we can see the Rootstock Testnet here. We can see it's created here, and then it's added to the networks array here. So we can see some metadata here, and then we can see some configurations here. So we can just take a look around, play with stuff, and see how it works. So what we're going to be focusing on, the two files will be the use write contract and then the app.tsx. Alright guys, so for us to get started, I think we should work on the hook first. So when we work on the hook, it's going to give us direction as to how we're going to manipulate the data from the UI and then pass it into the hook, because this hook is what is going to be like our interface to the smart contracts. Now let's look at the smart contract. I believe we've looked at it earlier, but then we can see it's a function. It receives an array of addresses, it receives an array of amounts, which is U256, does some checks, then it gets the sum of the amounts, then it also does some check to ensure that the person calling the function passed in some RBTC. So that's what msg.value here is doing, and we're not checking that okay, this amount it's sufficient enough to be disbursed. So based on the amounts that were passed in, then we do the dispensing here, then we return. So this here just like a refund in case the amount that was passed into the function was like more. Alright, so that's basically what's happening on the smart contract. So representing the smart contract here is the ABI. ABI stands for Application Binary Interface. So it represents the smart contracts, and then this is it here, the function signature. we have the addresses, we have the amounts and everything. So this, we can see this API also in the use contract. So it is what was used to build the contract object. So in our hook, we're not going to be using, API directly. We're just going to be using the contract object that was created. So now let's get started with writing some code. Okay, guys. So we're going to firstly, we're going to import the contract hook. So we're going to say const payroll, and this will be use payroll contracts. Okay, so let me call this payroll contracts. Okay, so now we're going to pass in true because this is a write. What we want to do is write. We want to write to the blockchain. So we need to pass in signers. So now we're going to check. Okay, I think another thing to do is we want to get the address from use AppKit account. So all we need here is the address. So we need to check if this is valid. Okay, so we're going to pop a toast message, toast the error. What's it going to say? We're going to say that the payroll contract is not found. Same way we did this, we're going to do for the address, but now we're going to say address not found. Okay, now after doing this, okay, just give me a sec, let me check if this is still intact. Now we're checking if the payroll contract is like if the contract object has been created successfully. So we are basically checking the truthiness of these two variables. After doing that, the next thing to do is we need to create some objects. So now we can say const is paying, so set is paying should be equal to use state. So this will act as a loader for us. This will act as a loader. Alright, so but this check should be inside the function. These two checks here. So let's create a function pay, and it will be the pay function will be a use callback because we don't want to avoid re-renders. So we're going to put it inside here. Okay, use callback. Now the dependencies are going to be payroll, contract, and address. Okay, so this is going to be outside because it's also a hook. So I'm going to put it outside. Great. So what we're going to export is we're going to export pay function, and we're going to export the is paying variable, state variable. Inside the function, what do we want to do? Firstly, this is actually going to be an async function. Yeah. So we want to have a try and catch block. And try and catch, what we want to do is inside the try, we're going to make the calls which mutate the blockchain states. And inside the catch, we're catching the errors. So in the try, we're making the call to the smart contract, passing in the data, and then the catch is catching the errors. So the error catching is going to be easy. So we firstly log the error. Then we need to create an object here, and the object is error decoder. So we're going to use the error decoder here, error decoder.create class. So the error decoder is a class here, and then it has the create function. So now this is what we're going to use to decode smart contract errors. So we say const decoded error. Okay, we're also going to use the decoded error class. Yep. Decoded error interface or type, and this will be equal to await error decoder dot decode. Yes, then we'll pass in the error. So that line decodes it. Then we need to pop a toast message. So we say decoded error dot reason. Great. Now we return false because in the try block we're also going to return some boolean which represents the state that says the transaction has been done correctly. But now since this is a catch block, we know that the default state is false because nothing was done correctly. Now in our try block, the first thing we want to do is we want to set is paying to true because that's going to initiate some loading. Like it's going to say, okay, something is happening already. So this is paying. It would help us control loading states on the in the UI side. So that means when the user clicks the button, we want to do some things like, okay, make this button not. Okay, now that this is true here, we will have a finally block set is paying to false. So that means regardless of, you know, the try or catch, when everything is said and done, we're going to set it back to false. So now within this what we want to try out is we want to create a transaction, and we'll do await here. So we're going to use the contract object that was created above, and now we're going to call the function distribute. So if you check the ABI, we see it's the distribute function. So we call distribute, and then we pass in what? The address and amount. So now what types? So addresses can be array of strings, right? So we can put array of strings as a parameter here. So we say addresses, and then it's going to be string array, right? But now for the amount, uint 256 are actually big ints. So we can say amount are big ints here, big int array. Then I think one more thing we need to do is we also need to have total amount, which is also going to be a big int. And why do we need this? I just want you to like think in your mind, like, okay, why do we need the total amount? So after passing in the address and we pass in the amount, why do we need total amount? Because if you look at the function signature, there's nothing like total amount, right? And now that is why, you know, you really need to read the contract to understand what is happening. So I mentioned earlier that it is using msg.value, and msg.value is like the it value that is sent with the transaction. Now in this case here, it in this case is representing the native currency of the Rootstock blockchain, which is RBTC. So in this case, total amount here will be passed in as a value. So we have value and then we have total amount, right? So I guess we're having an error here. So let's see. Okay, this is outside, supposed to be inside it. Okay, great. So it says this is possibly null. This is possibly null. Why? Okay, we're supposed to return here. We're supposed to return false, so it ends, it breaks here. I think that was the error. Yes, so I think we're good to go now. Now that we've created a transaction, we want to create the receipts. Okay, so this is await paytx dot wait. So what this does is it causes this function to wait at that point till the transaction is mined on the blockchain. So once that is mined, then it generates a receipt. And now we will say return receipt dot status equal to 1. Now what this is doing is, okay, was this transaction successfully mined? If the transaction is successfully mined, then the status is going to be 1, so to return true. Then else, then you know we have a catch block here. So guys, our hook is ready. So now we already have direction, right, on what we are passing in here. We're passing in addresses, we're passing in amounts, and then we're passing in the total amount here. Let's go back to our UI and see what we have. So we have rows here, but rows is an object containing address and amount. So we need to find a way to split the two of them into like two different variables that we can pass directly. Also, if you look at the send payment, we see we are doing inside the loop, we are doing some verification, like validation rather, using this regex. Okay, so the regex checks for the address, if the address is valid or not. So it's also an alternative to using ethers.isAddress. So we're also checking for the validity of the amount. Yeah, the validity of the amount and empty fields. So that means if we want to do the splitting, we want to do that after here, right? We want to do that after this point. So what we're going to do first is we're going to create some states. We're going to create some states here. We're going to create, and the states we're going to create are to store. We're going to create states to store the addresses, to store the amount. Then we're going to say const all addresses, then const all amounts. Then we also have one more thing to store, and I guess you figured it out. So it's going to be total amount, and that's going to be a big int. So you can see it's a big int. So what we want to do in here is, since we trust that whatever reaches this point, whatever data reaches this point is valid, then we want to convert, first we want to convert the amount to big int. And ithas gives us a method. So we're going to use a try catch block here, and then in the catch block we simply want to just pop a just message and return out of it. So it simply says row, this has an invalid amount. So the row is referring to here would be like the row. So it uses index to track the rows using the for loop here. So in the try block, we're going to convert the amount. We're going to say amount equals ethers dot parse ether. So now parse ether here simply passes based on the native currency. So now we're going to pass in row the amount, and then we're going to add total amounts. So amounts. So for each of them, it is incrementing total amounts. Now the next we want to do is we want to push the address, row.address, and then we also want to push amounts. But now we are not pushing row.amount because row.amount is a string. If you look at the type definition, it's a string. But what we need is the big int type. So we're going to do amounts because this amount is row.amount but has been passed into a big int. Okay. So now that we have these guys, we want to log console.log and say, okay, all addresses. Okay, I think this, I say all, okay, it's supposed to be addresses. So let's correct that, addresses. So then we also have all amounts. No, let's do total amounts. That's going to make much sense. So total amount, and yeah, so let's test out the UI. Let's see if the server is running. Cool, runs. So we reload because sometimes the browser caches states. So let's connect. So now we've connected our wallet. If we try to send, so we see row 1 is incomplete. That's because we have empty rows here. So let's try to pass in some data. So I'm going to use my wallets, my dev wallets here, passing 1 in the second one. So for the second one, now for the amount, we're going to use small values here because I don't really have so much. I only have 0.001. I can say, okay, 0.0001. Yeah, I'm stingy right now. Okay, so let's say 0.02. Let's say 2. So let's 0.02 here. All right, so we expect that the totals to have the fifth decimal as 4. So let's do send payments. Okay, the toast message comes out, and then if you check the console, we can see this. We can see, okay, correct, convert to big int, and you can see that it's not 0.00. It's now showing like an actual big int because, now let me explain this. So if we see the address too, okay, this is correct. So what happens here is that on the smart contracts, what we want to pass to the smart contracts as amount here we don't want to pass in something like 0.01 because this is actually a very small number, but then if we do as we passed it to big int using ethers, what it did was it multiplied this with 1e18. So that's what we're having, like multiple zeros, and then we have an n at the end because this is actually the representation that we want and we need. So what we are saying is we want 0.01 CRBTC, right? CRBTC. Well, now CRBTC in actual way, right? In way, it is multiplied by what? 1 e to the 18. Yeah. So this is what will give us the actual value that we need. So guys, ensure that your manipulations are done correctly. So now back in app.tsx, what we want to do now is here we delete this since that works. Now we are going to define this variable is payment successful. Now this is where our hook will come in. So we make this async, then we import the hook const use write functions. Now we are importing pay and is paying. Great. Now is paying is for the loading state. So now let's handle our loading state. So the first thing is we want to disable the delete button. This button, yeah. Want to disable it when is paying is true. We also want to prevent the person from adding rows when the transaction is being mined. So we say disabled. I mean, you can think of better ways to do this, but like this is like the easiest way. And then we also want to have a better this thing here. So we can say is paying. When is paying, we want to say sending, and else we want to send payments instead. So this works. Now this is the loading state that we envisioned. So you can actually use like a button loader or some fancy method of loading. So now here we're going to say await pay, and then pay accepts addresses. So we say all addresses, then we say all amounts, then lastly we're going to say total amount, sorry. Now we can see how the fact that we created our hooks at first made it easier for us to like navigate the UI data manipulation properly. So if you had done the data manipulation here first, you now have to like be working, you have to do extra work on the hook side to make sure that the data here works there, which is kind of like harder. So we like start from where we are actually going to, then we work backwards. So now if payment is not successful, what we want to do is we want to return, because already in the hook we already have a catch block which will handle the errors accordingly. Then else we want to pop just message which says paid all addresses successfully. So guys, here we have it. We successfully integrated the hook already. Now to test this out, let's disconnect this, we reload. Now I want to, okay, so these are smart contracts. I want to check some addresses. So like the two addresses I had here, I'm going to check them on the Explorer. Oopsies. So I'm going to just check them on the Explorer here. So we say block scout. The second address is this. I'll check this here. Now if you check them, we can see the amount of RBTC that this person has. So you can see the fifth decimal here is 2. We can see the fifth decimal here too also is 2. So if we send 2 to the fifth decimal, we expect these 2 to increase to like 4. Okay, so this is what I mean. Let's connect. Okay, now that we're connected, I want to put in this address. So you can copy from here. I want to put in the address here. So sometimes copying from the Explorer could actually cause some errors, but I hope it doesn't. I just hope. So we say 0.123455. Then I'll copy the second one. Wait. Are they the same? Oh wow, they're actually the same. I didn't copy the second one properly. So this is the second one. Alright, so I'm going to paste that here. Okay, so yep. So we can see the amount here too is the same. So I'll paste that in here. And then 0.00002. So let's see. Let's click payments. Good, bad, address checksum. I know that would come from this guy, the one that I copied from the Explorer. So let's copy from here. Let's see if it will work. Okay, great, it's working. So signed in. So it's supposed to pop up our connected address, our connected wallet, but that isn't happening. Okay, so let me check. Okay, could not current error. So let me end this, disconnect this. Okay, I'm going to reload this and I'll start the server again. Alright, so let's go. So we connect. So let's paste in those addresses again. Say 1 and the second one, 2, 3, 4, 5. 0.1, 2, 3, 4, 5. So let's try sending again. Great, so the pop-up worked. So that could have been like state, the browser caching the states, the React state. So it happens a lot. So try to, when you experience this error, reload your browser. So now we sign this transaction and then we see that it's mining. So we give it some time depending on the strength of your internet connection. And then, looking at the UI, you could extend this, you could make it better, you could use modals and whatever you want. So this is like a very simplistic design, but I trust that you guys are going to like we are going to do more complex stuff. So this is still mining. Oops, my internet connection. So I want you to see like the pop-up message. Okay, this is still mine. It should take a few seconds. Okay, good. So we see paid all addresses successful. And we see my wallet gives me a pop-up too. So now what I want to do is I want to go back to those addresses to see how you have increased. So this is still 2, right? If we reload this, we should see an increment. Good, so we see 4 now. So there's an increase here. Same thing for this guy. Reload, we should see an increase to 4. Good, so that means that the transaction was successful. The payment was disbursed to the right addresses. Another confirmation you can do is, check the contract itself. Check the contract itself. You see the transaction. You can see the Rootstock Explorer also tracks the amount. So we can see 0.04 here. This was what we distributed. We can see what exactly happened. So guys, we've been able to do this successfully. We wrote, we built the UI, we did the logic, we did data manipulation, and guys, that's how, we build a payroll system on the Rootstock Testnet. Now, we can see errors too, but let's check out some things about errors. And if we do this, let's say we use an address. Okay, we already saw that when we use an address with the wrong checksum, and we say, okay, popped up that, okay, it's an invalid address. I wanted to just portray that what we used here, the decode error here, using the error decoder, is very efficient for handling errors from the smart contract. Although what we saw here was not from the smart contract, it was from our validation logic, which we used in the app here. We used in app.tsx. But then that still works. Okay, so guys, feel free to extend this in terms of UI design, in terms of functionality. It's been a pleasure like bringing you guys on this journey. And guys, ensure you build on Rootstock. It's a very wonderful chain. It's an EVM compatible chain, and there are lots of opportunities for developers and everyone. Thank you guys for watching.